These are the different types of drawing that we were discussing. And out of the engineering drawing, we have two different types of drawing, that is building related drawings and then machine component drawings. And these two types of drawings can be either orthographic projection or it can be isometric or perspective projection. So in orthographic projection, it is also known as a multi-view projection because it needs more than one element or one drawing to get it. So see, this is an element, this is an object, this is an object. And in order to represent this particular object, we need at least these three drawings. Or even at times, only two drawings can solve the problem, but at least two drawings is necessary. With only one drawing, we cannot represent it completely. So that is why it is known as the multi-view drawing. And then the drawing can be either a front view, top view and side view. And what are the terms, why it is known as front view, why it is top view, etc. that we will come to later. And then in the other case, that is the three-dimensional drawing or the pictorial representation. It is also known as a pictorial representation. In that case, we need only a single type of drawing. So it can be either an isometric drawing or it can be a perspective drawing. Isometric drawing is mostly followed by mechanical engineers and perspective mostly by civil engineers. So this is the isometric drawing and this is the perspective. So by seeing the picture itself, it can be seen that it is some sort of a cube. By seeing these pictures, just by seeing only these pictures, it is very difficult to understand what is the shape of the actual object. So that is the difference. So now we are coming to the orthographic projections. The orthographic projection, actually it is just a technical drawing in which we need different views. As I said, it can be front view, it can be top view, it can be side view. A combination of these all three views should be there. Only a single view may not be able to represent all the features of an object. So that is why it is multi-view projection. So, and it is projected on different planes. In order to prepare the orthographic projections, we need different planes, different reference planes. And these reference planes or the projections, the projection is done perpendicular to the reference planes. That is why it is known as orthographic. Ortho means 90 degree, not in medical terms, but in engineering terms, ortho means, or in scientific terms, ortho means it is 90 degree, that is perpendicular. So we are projecting this thing in perpendicular to a specific plane. That is why it is orthographic projection. In order to show about or understand the projections, I can give you a very simple example. I don't know how many of you might have seen the older film projection method in which the films were physical films itself, the pictures, the movies were physical films itself. And a light source was used to project the content of that particular film onto a screen in front of you. So that you might have seen. Or another condition is you might have created shadows you are using your hands. Shadows of different shapes using your hands on a wall. So that is a type of projection. Or you might have reflected the rays of sun, the sun rays to inside to a hole. So that is different types of projections or different modes of projections. So in that case, what you are doing is you are sending a beam of light or a number of rays of light, infinite number of rays of light will be there, to a specific plane. The plane is the plane on which the particular shape, the shadow, the movie, or the light is reflected, or light is being displayed, not reflected, is being displayed. So it can be either a wall, a perpendicular wall, or it can be a horizontal wall or a horizontal floor, etc. So these are the reference planes. So a reference plane can be a vertical wall or it can be your floor. So the vertical can be wall, can be either the one which is in front of you or towards your right or left of you. So there are two different sort of vertical walls are there. Then the horizontal wall is also there. The horizontal wall, not wall, it is the floor. The floor is there. So these are the reference planes. We can consider these to be as the reference planes onto which the projections are made. And in the case of movies, you might have seen that in the case of movies, the light source is starting from a very, almost like a single point. It is starting from a bulb or from a very small aperture. So then it goes widening. It goes widening in such a way that it fills the entire screen. It fills the entire screen. So that is the way the movies are being projected. If you use a torch, if you use a torch to create shadows of your hand, again it is almost the same thing. The shadow will be larger than your hand. So it is not perpendicular projection. The rays of light are not falling on the wall in a perpendicular manner. But on the other hand, if you can place a particular board of any nature, not a transparent one, a particular board which is an opaque one, against the sunlight in such a way that the shadow of the thing that you want to make, say your hand itself, or say any book, if you make a shadow of that one, and the shadow is of the same size as that of the object itself, in that case, the object as well as the plane on which the shadow is made, is perpendicular to each other, I mean parallel to each other. So in that case, the rays of light falling on the plane will be perpendicular to the plane. So that is why it is known as orthographic projection. So orthographic projection is nothing but when the rays of light are traveling perpendicular to the plane on which the shadow is generated. So the projection is nothing but creating shadows. Your first thing that you have to understand is it is nothing but creating shadows. The projection is nothing but creating shadows, and while creating shadows, you have to identify the shape, how it is being generated there, and what will be the shape, what will be the features of that particular shadow, the length. So that is the initial condition. That is the rays of light creating that shadow is traveling perpendicular to the plane on which this particular shadow is made. That is why it is known as reference planes, orthographic projections. And then the different reference planes, it is not a difference plane, there is a typing mistake. Actually, it should be reference planes. It can be a horizontal plane. The horizontal plane can be the floor on which you are standing or you are sitting. So that is the horizontal plane. The horizontal plane can be considered as a plane which is horizontal to your horizontal to what you say to the plane, to the ground, horizontal to the ground. Any plane which is horizontal to the ground is or parallel to the ground is a horizontal plane. So it can be assumed that the floor on which you are sitting is the horizontal plane, and the vertical frontal plane. So there is the horizontal plane is commonly denoted as HP, horizontal plane, short form of horizontal plane, HP. So whenever I say HP, it is not Hewlett-Packard, it is horizontal plane in engineering graphics, at least for while we are talking about engineering graphics. So the vertical frontal plane, the second important reference plane is the vertical frontal plane. So vertical frontal plane is, you can assume the vertical plane to be the plane which is, or the vertical wall which is in front of you in the room. You are sitting, I hope you are sitting inside a room, and the vertical wall in front of you can be considered to be the vertical plane or vertical frontal plane. So that is the VP. And the side plane or profile plane. It is both are the same. The side plane as well as profile plane, both are the same. You can assume the plane that is or the vertical wall towards your right or towards your left as the side plane. Why it is known as profile plane, that we will come to know. Profile plane is nothing but a side plane. Side plane is also known as a profile plane, or it is commonly denoted as profile plane itself. So PP, it is profile plane. So it is not of much use to us. It will be of use for some problems, some theoretical examples. We need profile plane, but in most of our problems we won't be much bothered about our profile plane. So it is, profile plane is nothing but it is a plane on your right side or left side. That is a vertical wall on your right side or left side. It is the profile plane. So horizontal plane, vertical plane, and profile plane or the side plane. So these are the three planes that are of importance to us. So let me show you how the three planes divide the entire space. See. So this is actually a representation of all these three planes. So in this case, we have three planes, one of red color, one of blue color, and the other one of green color. Three planes are there. The red plane can be considered as the front plane. So likewise, if I orient it like this, the front plane or the vertical plane is the red plane. The red plane is the vertical plane. And if I put it like this green plane is the horizontal plane. The horizontal plane is the plane on which the object is lying or object is normally resting, unless and otherwise specified. So this is the horizontal plane. And this blue plane is sideways to you. So you, in all the cases, you will be looking directly into, if you are standing straight, then you will be looking directly into the red plane, that is the vertical plane. So that is how it is. So if I show you the front view of this particular item, it will be like this. This is the front view. That is, whatever I am seeing, if I look straight into that particular object, that is the front view. Or otherwise, the front view is nothing but if I project a parallel source of light, if I project the rays of light from a parallel source of light into the object, and I made the shadow to fall on a vertical plane, then that particular shadow is my front view. So front view is nothing but the view that we see when we look straight into that particular object. That is the front view. And in other words, if we consider the concept of projection, that is the concept of shadow, then it will be the shadow that is generated by a parallel rays of light on a vertical plane. So that is the front view. So like, let me show it, explain it. So I hope you can see the object. The object is like a step. So let me just hide it. Okay, this is the object. This is an object for which I want to create the front view, top view, as well as side view. So this shape is like a step. So what I want to give is the shape, and the steps are of different color. This is to differentiate the steps, the two steps when you see the front view. So we have three planes. If I see it in the front view, it will be like this only. So it will be only this much part will be visible to me. If it is an orthographic projection. In orthographic projection, if I go for front view, I will be able to see only this much part. That is the vertical height. The vertical height of both the steps will be visible to me, as well as the width will also be visible to me. And if I go for the top view, Again, almost the same picture will be visible to me. But in this case, this height, this particular height is different. This is the width of that particular step, this height, the height of this rectangle, this distance. That will be the height of, see, this distance from this point to this point. If I measure this distance, this will be the width of that particular step. That will be the width of the step. But in the previous case, when I saw the front view, it was the height of the step. So in this case, in the top view, I cannot get the height of the step. In the top view, I cannot get the height of the step. And in the front view, I could not get, what was it? It was, we could not get the width of the step. So that is, in one view, we cannot get all the dimensions. So that's it. And if I go for the side view, if I go for the left side view, it will be like this. So it will be like this. See, this will be the side view. In this case, I am not able to get the total length of the step. I am not able to get the total length of the step. So in orthographic view, the difficulty is that we cannot represent the length along the direction in which we are looking. So that is the difficulty with orthographic projection. So if I make it, okay, if I look into the front view, as I said, this is the vertical plane, and on the vertical plane we will get this particular view. And we are drawing this particular view on the vertical plane. The front view will be drawn on the vertical plane only. So that is for another concept. So let's come back to our original presentation. So I hope you understood what is a front view, what is a top view, and what is a side view. Front view is nothing but the view that we obtain when we look from the front. And the top view is nothing but the view that we obtain when we look from the top. And side view is the view that we obtain from when we look from the side. And why it is known as projection? Actually, we are not looking and drawing it. Instead, what we do is we create shadows of the object on the reference planes. We have three reference planes. One is the vertical plane, another one is the horizontal plane, and the third one is the side plane. So these are the three reference planes, and we create shadows of the object on these particular planes. That is why we call it as projections. Even though we look into it and try to figure out what is the shape, what we actually does is we create a shadow of the actual object on the vertical plane. So that is why it is projections. So now come back to our presentations. We have three different planes. We have discussed about the three reference planes that is important to engineering graphics: the horizontal plane, the vertical plane, as well as the profile plane or the side plane. Now, another important things are the three different views. The three different views are the front view, top view, and the side view. Obviously, there is the bottom view, back view also, but normally we are not much bothered about all those bottom view as well as back view. It can be used only when some very intricate features are there which cannot be represented in front view as well as top view. But in our case, in our engineering graphics case, it is not of use because we are not bothered about so intricate shapes. We are bothered about only the regular shapes. So don't bother about those bottom views as well as what you say back views. We are bothered about only three views. That is the front view, top view, and the side view. The side view can be left side view or right side view. Normally we go for the left side view, but at times, sometimes we may have to go for the right side view also. So in normal case, we don't have to go for the side view in our engineering graphics course. But in some cases, in some specific cases, we need the side view also. So there are three different planes as well as three different views. Three different planes are horizontal plane, vertical plane, and side plane or profile plane. And in horizontal plane, we get the top view, and in the vertical plane, we obtain the front view, and in the side plane or profile plane, we obtain the side view. So these are the three planes as well as the three views, and the relation between these two things, that is planes and views. So the horizontal plane is, that you have to remember anyway. So the horizontal plane, HP, is related to this top view. It is in horizontal plane you obtain the top view. And this thing, that is the vertical plane, that is related to the front view. So that is in the vertical plane we obtain the front view. And obviously there is the side view. The side view is nothing but the plane, the view that we obtain in the side or profile plane. So these are the three different planes as well as three different views. So that statement is what we have discussed right now is emphasized here. That is, front view is a view that is projected on the VP, and top view is a view that is projected on HP, and side view is a view that is projected on the profile plane or PP. So that's it. And there are three important concepts of orthographic projections. One is the planes. The planes are the reference planes that we have already discussed, the three important reference planes. Actually, there are one more, actually not one, two more planes are there. Not much important to us. Then the second one is the pattern of planes and the pattern of views, because all these three planes, the horizontal plane, vertical plane, and the side plane, if you look into that thing, that concept, all these three things are in three dimensions. You cannot represent all these things in two dimensions. You can represent, but directly you cannot represent all these things into two dimensions. So you need some specific concepts or conventions to convert this three-dimensional thing into two dimensions. As I said, the horizontal plane, the vertical plane, and the side plane, it constitute something like a room, something like a box. So that box cannot be directly converted into two dimensions. Your drawing is in two dimensions. Your paper is in two dimensions. So you have to convert this three dimensions into two dimensions. And for that one, you need some conventions. So that is this, the conventions, that is this pattern of planes and pattern of views. So all the three planes as well as all the three views are in three dimensions. It is lying in three dimensions. They are not three-dimensional object. Each plane is two-dimensional object. But all these things together constitute a three-dimensional orientation. So that particular three-dimensional orientation, but all these things are two dimensions. That is, horizontal plane is two dimension. Only a single plane is there, so it is two dimension. Vertical plane, only a single plane is there. It is again two dimension. Profile plane, again two dimension. But if we arrange all these things in the proper way, it becomes a three-dimensional thing. So we need some conventions to make this particular two-dimensional objects that is arranged in three dimensions to again make it into two dimensions. So that is the pattern of planes and the pattern of views, how each plane will be displayed on two dimensions and where it should be placed. So that is the pattern of planes. And then the method of drawing orthographic projections, and what are the different methods of drawing orthographic projections. So the planes we have already discussed, but again for the completion of the thing in the presentation, planes, the principal planes are HP and VP, that is the vertical plane, and the horizontal plane. In most part of this presentation, the blue plane represents the vertical plane and the green plane represents the horizontal plane. The blue plane represents the vertical plane and the green plane represents the horizontal plane. So these two are the main planes that we will be considering, only the horizontal plane and the vertical plane. We are not much bothered about the profile plane. In some cases, we need the profile plane, but it is normally not used, because unless we need the side view, as I said earlier, we need only the front view and the top view for most of our problems. Side view is required for us. In most of the problems, I'm not saying we never will use it, but we will use it at some specific cases. Otherwise, we need only vertical plane as well as horizontal plane. And there are some auxiliary planes. Other than the principal planes, there will be some auxiliary planes. Auxiliary plane is any plane that is perpendicular to at least one of the planes, one of the principal planes. Any plane that is perpendicular to at least one of the principal planes, that is an auxiliary plane. So it can be an auxiliary vertical plane. An auxiliary vertical plane can be assumed that do you have an almirah in your room? If there is an almirah in your room, you just tilt it in such a way that it makes some particular angle. It makes some particular angle with the wall. If you tilt that, or even if the door can be made like an auxiliary vertical plane. You open the door halfway. Now, the particular door is perpendicular, not halfway, such that it makes an angle of 90 degree with the vertical plane. Instead, it will be making some angle in between 0 and 90 degree. Make the door in such a way that it makes some angle, not 0 and 90 degree, with the vertical plane or with the wall. In such a case, that can be considered as an auxiliary vertical plane. An auxiliary vertical plane is a plane which is perpendicular to the HP, that is perpendicular to the ground. And now, if you look into that particular door, it is perpendicular to the door, perpendicular to the floor, that is perpendicular to the HP. But it is making some angle with the vertical plane or some angle with your wall. So that is an auxiliary vertical plane. And auxiliary inclined plane. Auxiliary inclined plane, that is a plane which is perpendicular to your vertical plane and inclined at an angle to the horizontal plane. For that one, there is no easy way out in that case. Okay, in that case, you will have to tilt your table. You tilt your table in such a way that it lies on the ground. In that case, if it lies on the ground in such a way that the plane of that particular table makes some angle with the ground, and it is made in such a way that that particular plane is perpendicular to the vertical plane or the vertical wall. In that case, it can be considered as an auxiliary inclined plane. So we can see, visually we can see. So this is HP and this is VP, and this particular one, plane, this particular plane, this is an auxiliary vertical plane. So it makes an angle of 90 degree here. So the angle between these two, this is 90 degree, but here the angle is not 90 degree. So that is, see, some angle is there. So that is phi. That is why it is not. That means this makes an angle of some angle less than 0, greater than 0 and less than 90 degree with the vertical plane. So that is an auxiliary vertical plane. And in the other case, auxiliary inclined plane. So here this angle is 90 degree, this angle. So the angle the angle between these two will be 90 degree. But here the angle is not 90 degree. This angle is not 90 degree. So that is the concept of auxiliary vertical plane as well as auxiliary inclined. And we may not use this too much in our course, but at times we may need it. And in that, at that time, I will explain the concept again, no problem. And the profile plane we have already discussed, which is perpendicular to both HP and VP. The profile plane is nothing but which is perpendicular to both HP and VP. So in this case, this particular plane, this plane is perpendicular to HP as well as perpendicular to VP. This is like our side plane. This is not like our side plane, it is the side plane. So these are the different planes. Actually, there are, we have to consider 5 different planes, out of which 2 are the principal planes, which are very important to us, or which are the most important planes to us. And then there is a profile plane, which is perpendicular to both HP and VP. Then there is an auxiliary vertical plane and an auxiliary inclined plane. Now, let's consider our horizontal plane as well as our vertical plane together. As I said, the horizontal plane is represented by green plane as well as the vertical plane is represented by the blue. So now, when the HP and VP coincides, a straight line is generated there. That you know, that is when two planes intersect with each other, a straight line is made. When two planes are intersecting with each other, there will be a line of intersection. In this case, when HP and VP intersect each other, the line of intersection is known as the XY line. And this XY line is also known as the reference line. XY line is also known as the reference line. And together, this HP and VP divides the entire space into 4 different quadrants. That also you know, you might have studied in your school days. That is, the HP and VP divides the entire space into 4 different quadrants. And the quadrants are named as first quadrant, second quadrant, third quadrant, and fourth quadrant. First quadrant is the space which is in front of VP and above HP. That is, it can be considered as the space that you are sitting in. The space, the room in which you are sitting in can be considered as the first quadrant. And the second quadrant can be considered as the room just behind the front wall. Just behind the front wall, there is a room. Assume that there is a room, even if it is not there. So that particular space is the second quadrant. And the third quadrant is the space below that particular room, below the second quadrant room, below the room which we consider to be the second quadrant. Below that particular room, if there is a room, that is the third quadrant. That is, the third quadrant is below the HP and behind the VP. Below the HP means below the horizontal plane, below the floor in which we are sitting, and behind the vertical plane, or behind the vertical plane or vertical wall to which we are facing. So that is the third quadrant. And obviously there is a fourth quadrant. And the observer always looks from this angle, that is from this angle. This angle is through the first quadrant and the fourth quadrant. The observer is always looking like this, that is from the first quadrant and the second quadrant. As I shown you in the front view, when I was displaying the front view, we were able to see only the vertical plane. No HP was visible in that case. So that is where the observer normally or always stands, normally stands in the case of orthographic projections. And if we use this one. The front view will be obtained in this plane or here. If we look from this direction, or if we project from this direction, the front view will be here, that is in the vertical plane, and the top view will be here in the horizontal plane. So this is the concept. And in order to get this, in order to convert this 4 quadrants into a 2-dimensional structure, or in order to express it more clearly, what I do is I look from this side, or let us look from this side, this red arrow, from the direction of the red arrow. If we look from the direction of the red arrow, none of the planes will be visible. Instead, only the vertical line and a horizontal line will be visible. Because a plane is a collection of straight lines. It is a collection of points, an infinite number of points arranged in a specific order. It constitutes a plane. And likewise, infinite number of points arranged in a linear fashion constitutes a straight line. So when we look at a plane from this side, if we look to this plane from this side, what we will see is only this edge. Only this edge will be visible to us. So that particular edge I am drawing here. So it is the vertical line. So this vertical line actually in this case represents the vertical plane. And this horizontal line actually represents the horizontal plane. So when I am looking from this direction, I can see only a vertical line and a horizontal plane. Horizontal line. Not just me, you also can see only these things. So now you can give or denote the line xy as a single point here. This point will be the xy, because it will be visible as a single point in that case. Now this is the VP and this is the HP. Now you can denote the observer. The observer is looking in this direction. So observer is standing here. So observer is standing here and looking in this direction. Now this is the first quadrant. The first quadrant means it is above HP and in front of VP. That is first quadrant. And now the second quadrant. Second quadrant means above HP and behind VP. So in this direction it is behind, and in this direction it is in front of. Since observer is standing here, VP is here, and if the object is in between observer and VP, it is said to be in front of the vertical plane. So here in the first quadrant it is in front of VP and above HP, and in the second quadrant it is above HP and behind VP, and in the third quadrant, what is the condition? Below HP and behind VP. So third quadrant is behind HP and behind VP and below HP. Below HP and behind VP. So what about the fourth quadrant? Anybody?
Below HP.
Yeah, below HP.
In front of VP.
In front of VP.
Yeah, in front of VP. Okay, very good. Excellent. So it is below HP and in front of VP. So that is the fourth quadrant. So all these 4 quadrants we have now found out. That is, in the first quadrant, it is above HP and in front of VP. Second quadrant, it is behind VP and above HP. Third quadrant, behind VP and below HP. And fourth quadrant, in front of VP and below HP. So this quadrant pattern, if observed along the XY line, will exactly appear as shown on the right side, and hence it is further used to understand the illustration properly. So using this illustration, using this particular drawing or particular illustration, we have to understand a number of things. So I hope this thing is clear to you. Is nothing but the different quadrants that you have already studied in your school days is revisited. Now, the pattern of planes and views, the first angle method. Why it is known as the first angle method? Let me show you. So when the object, if we consider the object as one thing which is staying here, that is in the first quadrant, and if we create the projections, the front view and the top view, then we call it as the first angle projection. And if the object is in the second quadrant, say here, and if we project it, we call it as second angle projection. And if it is in the third quadrant, if the object is in the third quadrant, then we call it as the third angle projection. And if it is in the fourth quadrant, then we call it as the fourth angle projection. So there are four different types of projections available. That is first angle projection, second angle projection, third angle projection, and fourth angle projection. But out of which, normally we avoid second angle projection as well as fourth angle projection. Why? That we will explain later. So commonly we adopt only first angle projection and third angle projection. That is when the object is in the first quadrant, or we place the object to be in the first quadrant, or we place the object to be in the third quadrant. That is the concept. So why it is so, that we will discuss later. So before that, let's see what is the first angle projection and how the pattern of the front view, the top view, and the side view will be visible to us. So let's see the pictorial representation of all the three planes. So here is the front view, I mean the vertical plane, the horizontal plane, and the profile plane. All the three planes are there. Now this is the XY line that we have already discussed. Now this is the view, the direction of the view in which the front view is made, and this is the direction in which the top view is made, and this is the direction in which the side view, the left side view, is made. Now as I said, this particular view is in 3 dimensions. I mean this particular arrangement of the objects is in 3 dimensions. The vertical plane, the horizontal plane, and the profile plane. All these three are actually 2-dimensional objects, but the whole arrangement is in 3 dimensions. So we have to convert this 3-dimensional arrangement into 2 dimensions. How to do it? What we do is, we first rotate the HP, the horizontal plane, 90-degree downward, or we rotate the HP 90-degree clockwise direction, in the clockwise direction. We rotate the HP in 90-degree clockwise direction. That is like this, 90-degree clockwise. And then the profile plane, in order to get the profile plane in line with, or in plane with the, not in line actually, in plane with the vertical plane, what we do is we rotate the picture plane 90-degree clockwise, anti-clockwise, in the opposite direction, 90-degree anti-clockwise. So like this. So now once this particular plane, the HP, is rotated 90-degree clockwise, it will be like this. So now this vertical plane as well as horizontal plane are in the same plane, are lying in the same plane. So now only thing is the profile plane. Now HP is rotated 90-degree downward and brought in plane with the VP. Now we rotate the profile plane again, 90-degree anti-clockwise direction. So now all these things are in the same plane. And now see, if the object is in the first quadrant, The object was in the first quadrant. So this is VP, this is HP. So any object that is lying here, that is in front of VP and above HP. In front of VP and above HP is first quadrant. And we obtain the front view here. Here is the front view, and here is the top view, and here is the left side view that we already discussed. So now what happens is the front view is here, the top view is here, and the left side view is here. It is in the same line. I mean, it is in the same plane. Now what we do is we convert this into a proper two-dimensional drawing. So this is our HP, this is our VP, this is our HP, and this is our PP. These are the 3 points. Okay, it is already there. So this is our VP, this is our HP, and here it is the picture plane. And this line marks our XY line. Here is the front view. Front view will be in the vertical plane, and the top view, which is in the horizontal plane, and side view, the left side view, that is in the picture plane. So this is the orientation in which if we draw first angle projection, the drawings, the different projections should be lying. That is, the front view should be above the XY line and towards the left side, and the top view should be below the XY line and just below the front view, in line with the front view. The top view will be in line with the front view. And how it is becoming in line with the front view, that we will discuss. So the front view is here towards the left and above the XY, and the top view is just below the XY line and in line with the front view. And the left side view, that is again this one, this is the left side view, that is again above the XY line but towards the right of our front view, towards the right of our front view. So that is the left side view. So this is the orientation of, or the arrangement of the objects, the arrangement of the different views in first angle projection. So in first angle method, the arrangement of the objects is like this. That is, the front view will be above the XY line, top view will be below the XY line, and the left side view will also be above the XY line, but towards the right of the front view. And in two-dimensional drawing, or in the orthographic drawing, this particular area marks the vertical plane, this area marks the horizontal plane, and this area marks the profile plane.